Hi, DDMonkey15. This is Sam from exampa.net. Here's a quick recording that answers your question. First of all, this is a really good find. So the December exam 2019 solution doesn't mention this specifically in the commentary. So your main question is, I thought immediately that this should be converted to a factor variable and regrouped to reduce the number of levels. Many levels had similar impacts on the target variable, so I grouped those and ended up with about 6 or so levels. So this is an interesting idea because if you were to include this as a factor with 16 levels, right, that would make the model much more complicated and it would probably result in overfitting. So is this a better method than using it as a numeric variable? Because as you say, in the data dictionary, it explicitly says, is an indicator of the amount of education. It is not the number of years of education, but a higher number of years. But a higher number does mean more years. So I tried out an experiment. So what I did is I took the solution file and I ran two models. The first was the default model, and then the second was the binned value. So I created a binned variable called education bin, and it used 6 levels. So let me find that really quick. There it is. So here you can see the different levels. So there's 6 different levels, and at minimum there are 2,000 observations in each bin. So the first bin captures levels 1, 2, 3, 4, 5. The second bin is 6, 7, 8. The third is 9 because 9 had a lot of observations, and so forth. And then I fit 2 different models. So I fit 2 different decision trees and 2 different GLMs. And then I looked at the AIC value and the AUC value. And here you can see the results. So for the decision tree, your method of including the bins improved the AUC on the test set slightly from 0.8347 to 0.8348. So that's good. For the GLM, however, it decreased the performance. The AUC was 0.8789 without the bins, but when you added the bins, it was 0.8775. Likewise, the AIC is lower, which is better. And that makes sense because when you don't use the bins and you only use a numeric variable, it only includes 1 additional coefficient. When you use the bins, it's going to include 5 additional coefficients, right? 1 for each of the levels minus the base level. And AIC is penalized by the number of parameters that are in the model. And so it makes sense that that would be slightly worse. But another factor is also the interpretation, because it's more difficult to interpret the multiple factor levels, whereas if you're just interpreting a single parameter for education number, you can just say, okay, as this education number increases, then the person's likelihood of being high value increases. So if you look in our study guide, we actually have a complete example of this problem that you can access for free. So if you go down to section 8.6.4, it says, which variables should be converted to factors and which should be numeric? Another question that you can look at is the hospital readmissions project, where there was a length of stay variable. Similar problem, similar concept. In this problem, though, I recommend that you use the numeric variable.